Okay, my name is Muhammad Afiq Ahza bin Muhammad Afiq. So I'm going to start off our project by explaining the question. Okay, so this is our question. Nazri wants to construct a box which has the base length of 3 times the base of width. The material used to build the top and the bottom cost $10 per feet squared, and the material used to build the sides cost $6 per feet squared. If the box must have a volume of 50 feet cubed, determine the dimensions that will minimize the cost. So after reading the question, this is the figure that we have found, or that we have sketched. A box, a rectangle which has height, node height, width, and only have the preference for length, which is the 3 times the length of width.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fareez Akmal, and my part is to explain about the minimum equation of the box, the volume, and I will calculate the first derivative and second derivative. We need to find the equation for minimum for the box. So since we know that top and bottom will cost $10 per feet, and sides will cost $6 per feet. So $10 times 2 LW for top and bottom plus $6 times 2 sides plus the other 2 sides equal to 60 W squared plus 48 WH. So second, we need to calculate the volume. So the volume is 50 feet cube equal to LWH for the formula. We plug in the value 3W2H based on this. Next, based on the volume, we need to make H as the subject. H equal to 50 divided by 3W squared. Next, we have find H, so we need to plug in into the first equation we have. C in the term of W equal to 60 W squared plus 48 W times by H. We calculate and we simplify, we get 60 W squared plus 800 W. Next is we need to find its derivative. So C, we differentiate the first equation equal to 120W plus 800W negative 2 equal to 120W cube minus 800W squared. Next, we need to find the second derivative. So we differentiate the first derivative. C double prime W equal to, differentiate this, so we get 120 plus 1600 W negative 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazri. So I will calculate and find W from the first derivative. So as we know, the first to get the minimum value, we must equal the first derivative with 0. So we take the first derivative from our last equation from there, and W cube minus 800 divided by W square equal to 0. So we move W to the right side, and W multiplied by 0 would be 0. So 120 W cube minus 80 equal to 0. We move all the number to the right side, so we just left W cube 800 divided by 120. 800 divided by 120 is equivalent to 20 divided by 3. So we move the cube to the right side, so it will be cube root the number 800 to 120. So we calculate it and we will get 1.8821. So we will get here W is equal to 1.8821. So
Warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Amaluddin, and I will continue to calculate length, height, and find the minimum cost to build the box from the original equation.
So since we have got the W equals to 1.881, so we need to find the value of H and L. So we know that L is equal to 3 times W. So 3, we just plug in the number 1.881 and equals to L equals to 5.6468. And next, we need to find H. H is equal to 50 over 3W squared. So we just plug in the W. Square, and the H value of H is 4.7050. So the question asks us to find the minimum cost. So we take the first the original equation, that is so we just plug in the value of W, which is 1.8821. And lastly, we got the minimum cost to build the box, that is 637 and 60 dollars.
Okay, so in order to confirm this value is minimum, so we use the second derivative from the previous calculation. The second derivative is C double prime W equal to 120 plus 1600 W negative cube. So we plug in the W value, so we get 1.8821 negative cube. So we calculate and we get this value, positive 359. So the positive value determine that the value in this equation will be minimum.